Now let's look at this reaction sequence for the production of sulfuric acid from iron pyrites. Now the first thing I'm going to do is I'm going to play with my equation. So I'm looking at the question and it tells me that I have 100 grams of iron pyrites. So this is my known. Now I'm going to eventually want to find out this one here. So to get from here to here, I need to adjust the ratios on my coefficients. So I've got 8 sulfuric acid here to 2 here. So I'm thinking what I need to do so that I can go from here directly to here is I need to adjust the coefficients. So let's have a look. This is 8 and this is 2. I'm going to multiply it by 4. So this now becomes 8, 4, and 8. It is still a balanced chemical equation. It's just not the lowest ratio anymore. Now the next one here is the sulfur trioxide, here and here. So if this is in 8, we need to make this one 8 as well. So we're going to times this one by 8. So we go 8, 8, and 8. So the next step is the sulfurics. So here we have a number 8. Here we have a number 2. We want them to be the same number. So I'm going to multiply this equation by 4. So this becomes 4 2s are 8, 4, 4 2s are 8, 4, and 4. So now our equation is ready to go. So, like any stoichiometry, once I've got my equation ready, I need to find the mole. So I'm going to start by finding the number of moles of iron pyrites, which is equal to a mass over a formula mass. So in this case, the mass is 100 grams, and the formula mass, which I get off the periodic table, is 119.99. And this comes out to a number of moles of 0.8334 moles. Now I'm going to store that in my calculator. Now the next part that we need to do is find our stoichiometric ratio between our known and our unknown. So the number of moles of sodium hydrogen sulfate will equal the unknown over the known times by the number of moles of what we do know, which is the iron pyrites. So in this case, the unknown was, what's the coefficient? 8. The known's coefficient is 4 times by 0.8334, and this will come out to 1.6668 moles. So now we've got our unknown moles. So the next step is to find the mass of the unknown. So the mass of the unknown, in this case, which is sodium hydrogen sulfate, will equal number of moles times formula mass, which is 1.6668 times the formula mass for sodium hydrogen sulfate, which is 120.068, which comes out to 200 grams. Now I need to check my significant figures. There were 3 significant figures here and there are 3 significant figures here. Let's read part 2. So in question B, it says what mass of sulfuric acid could be produced. So we need to go back to our equations again, and we can see that 4 moles of iron sulfide will produce 8 moles of sulfuric acid. Now we've already calculated the moles of iron sulfide, so I'm not going to do it again. Why would I bother? So part B, we just need to do our stoichiometric ratio. So the number of moles of sulfuric acid will equal unknown over known times the number of moles of iron sulfide. So in this case, using the coefficients, you can see sulfuric has an 8 and iron pyrites has a 4. So it's going to be 8 over 4 times 0.8334 moles, which comes out to 1.6668 moles, which is the same as the other one because they're in the same stoichiometric ratio. The next step now is to find the mass of sulfuric acid, which is equal to number of moles times formula mass, which is 1.6668 times 98.086, which I got off the periodic table, which is equivalent to 163 grams. Remembering, of course, that we have to give our answer to 3 significant figures. Now let's look at part C. So part C says that we have to find the mass of oxygen required. Now this is a little bit tricky. So if you look at our equations, you can see here that we had oxygen here and oxygen here. In fact, we had 11 plus 4. So 11 plus 4 is 15. So the number of moles of oxygen will equal the unknown over the known times the number of moles of iron pyrites. The unknown was 11 plus 4, which is 15, divided by iron pyrites coefficient, which was 4, times by 0.8334 moles. So this comes out to 3.125 moles. And of course the last step is to find the mass of the oxygen. And the mass of the oxygen is equal to number of moles times formula mass, which is 3.125 times 32, which comes out to exactly 100 grams, to 3 significant figures.